This is the second part of my video on thermodynamics. So we want to give the condition that is necessary for a reaction to be spontaneous. First and foremost, we will need to rewrite the equation derived earlier in my first video. In that equation, we said delta G, which is Gibbs free energy, we say is equal to delta H minus delta S with T here. Alright. Now, if the enthalpy change is positive, which means endothermic reaction. Which means what? Endothermic reaction. If it is positive, then you place your positive here. If this is also positive, you place your positive here. Then what is going to happen? If this is positive and this is positive, then what is going to happen is that minus times positive, I will get negative. But this will be positive. Now, if this is positive, it means if this one is very large, my answer will be positive. But if this one, if the temperature is very large, then it will be negative. It means this thing is going to be positive, but if the temperature is very large, then it is going to be negative. So here now, minus T. Now, since this is positive before, the whole term here will still be negative. So I have negative here. And then what I'm going to have here is that this thing will be positive. But at very high temperature, it will be negative. So what is going to be my comments? Non-spontaneous, spontaneous at high temperature. At high temperature. Alright, let's move on. If this is positive again and this is negative, what is going to happen? Then this is negative, negative times negative, that will be positive. Negative times, okay, before I do that, let me finish this one. If this is negative, the whole term here, negative times negative, that will be positive. That will be positive. Now, since this is negative, negative times negative, that is positive. So the whole term here will be what? Will be positive. Let me come again. Positive. This one is negative. And since I have negative here, negative times negative, I will get positive. So everything will be positive. So delta G will also be what? Positive in that case. And that simply means non-spontaneous. Non-spontaneous. Okay? Now, if this is negative and this is positive, applying the formula again, delta G is equal to delta H minus T delta S, the whole term here. Let's start with that. If the entropy here is positive, entropy is positive, the whole term here will be negative. And this is negative. That means this thing will be negative. The whole term here is negative already, and everything is negative. That is a spontaneous reaction. Spontaneous reaction. That is spontaneous reaction. Spontaneous reaction. Spontaneous at all temperature. Spontaneous at all temperature. Okay? If this is negative again, and this is negative, I will put down the formula again. This is a delta H minus entropy change. Now, what is going to happen to this term again? From here, this entropy is negative. So this is negative. Minus times minus positive. So the whole term here will be positive. Alright? So if the whole term is positive, then this one is negative already. Negative. Alright. So what is going to happen is this. If this one is very low, okay, negative and positive, our answer could be positive, our answer could be negative, depending on the value. So if this thing is very high, of course it will be positive. If it is very high, it will be positive. But if the temperature is very low, the whole term will be negative. The whole term will be what? Will be negative. Let me come again there. We don't have problem with the whole term. The whole term here, since entropy is negative and the symbol here is negative, when you multiply we get positive. Now when we have minus and plus, for instance, our answer could be negative, our answer could be positive. It depends on the value of the term here and the term here. Now if the temperature is very high, then we are very certain that our value will be positive. But if it is very low, our value will be what? Negative. So if it is very high, it will be positive at high temperature. Positive at high temperature. Positive at high temperature. Negative at low. Spontaneous at low temperature. So that is all. Let us revise this to avoid any unnecessary mistake. One thing is very, very important here. For us to have a spontaneous reaction, entropy change must be positive. So here, this is what occurs. Another one here. This is what occurs. Another one here. So, but here now, when it is negative, that will be at very low temperature. Can that be correct? I don't think so. So this is positive, this is positive. This one is better. But here now, our entropy is negative. Since our entropy is negative, it is difficult for this thing to be spontaneous. Let us check our formula again and let us see where the mistake comes from. This is equal to enthalpy change minus entropy change, then multiply by T. Okay, now enthalpy negative. The whole term here will be positive. This is negative. So if everything here is positive and what we have there is negative, then two things can occur. Yes, if the temperature here is very large, positivity will be large and we get positive answer. But if it is very low, positivity will be very low and negative will take the lead. So what we have written is correct about that. Let me now check this one as well. This one. Okay, in this one we have this, which is equal to enthalpy change minus T entropy change. If this is positive and this is positive, the whole term here will be negative, the whole term here will be positive. Now, if this thing is very large, of course, this one will carry the lead. But if it is very low, if T is very low, this one will carry the lead. I think we are correct in that sense. So, the major condition here is that for a reaction to be spontaneous, the entropy must be positive. But there are some occasions where it can be negative. When it is negative, then the temperature must be very low. But when it is positive and the enthalpy change is negative, no doubt about that, then it will be spontaneous at all temperature. It will be spontaneous at all temperature. So thank you again for watching my video. Look at the table very well and understand the table. So by looking at the table, you will understand how to answer questions either on JAM, WAEC, NECO or JUPEB. Thank you again for watching my video. Please don't forget to subscribe to my channel. Don't forget to subscribe to my channel. Just go to YouTube, type Tutopedia Tutorial Center. The moment you get there, you see all my video, press subscribe, and then you will see a notification bell. Press on that notification bell. Anytime I have my video, you will be notified on my video. In my next video on thermodynamics, I'm going to look at how to solve the question on this JUPEB past question. Thank you again for watching the video.